This is the title of the problem. It tells us we'll be working with Sklearn, a popular machine learning library in Python, and focusing on evaluating a model's performance using the F1 score. Sklearn, is an incredibly useful tool for building and assessing models. The F1 score is a great metric to check the balance between precision and recall of a model. This section clearly lays out the challenge. I need to select the correct code snippet from a list of options that creates a scorer for the F1 score, while specifically accounting for imbalanced classes. The problem highlights the significance of handling imbalanced datasets in machine learning. This option uses _make_scorer to create a scorer. The _average equals weighted argument within the F1_score function is key because it calculates a weighted average of the F1 scores across classes, considering class imbalance. This is a clean and efficient way to do it. This option accomplishes the same task as option A but uses a lambda function to wrap the F1_score call. It's functionally equivalent, although perhaps a bit less concise. The lambda function is essentially an anonymous function that's created on the fly. It takes true and predicted labels as input and computes the weighted average F1 score. This option is incorrect. _average equals binary is designed for binary, two-class classification problems, not for multi-class problems with imbalanced data. For this, I need a weighted average F1 score. This option is also incorrect. Setting _average equals none returns the F1 score for each class individually, not a single weighted average across all classes. The problem explicitly states the need for a single, weighted F1 score. I'm looking for the right way to calculate the F1 score when classes are not equally represented in my data. This is important because a simple average F1 score can be misleading in such cases. I need a scorer that accounts for the class imbalance by weighting classes inversely to their frequency. That means classes with fewer samples should have a greater impact on the overall F1 score. Here's the key concept. The weighted average of the F1 scores for each class means we consider the number of samples for each class. Imagine we have three classes, A, B, and C. Class A has many samples, Class B has a moderate number, and Class C has very few. A weighted average F1 score will give more importance to the F1 scores of classes B and C because they have fewer samples. The final F1 score reflects this imbalance. This is what is needed for imbalanced datasets, making it a fairer representation than a simple average. This is a correct way to create my scorer. I'm using _make_scorer from Sklearn, and I'm telling it to use the F1_score function with the _average parameter set to weighted. This parameter will calculate the weighted F1 score I need for imbalanced data. This is a compact and direct approach. This also works perfectly. Here, I'm using a lambda function to wrap the F1_score function with the weighted average. It achieves the same result as option A. It's functionally equivalent. While more verbose, it explicitly shows the function being passed to _make_scorer. This will not work for my problem. The _average equals binary option is only appropriate if I have only two classes. I am dealing with more than two classes with imbalanced data, so this is not suitable. This also won't work. The _average equals none option returns the F1 score for each class separately. What I need is a single, overall weighted average F1 score, not multiple scores for individual classes. It won't give me the single metric I need for comparing models. I'm tackling the challenge of building a scorer that accurately assesses a classification model, especially when dealing with datasets where classes have uneven representation. The goal is to use Sklearn's F1_score function. But I need to handle the imbalance by weighting classes proportionally to their inverse frequency. It's all about getting a fair and robust evaluation. This option directly uses the F1_score function with the average equals weighted argument. This tells the F1_score function to calculate a weighted average of the F1 scores for each class, weighting each class by its support number of samples. I think it's elegant and efficient. Here, I'm using a lambda function as a wrapper around the f1_score function. The lambda function simply takes the true and predicted labels, y_true and y_pred and applies the f1_score with the average equals weighted argument. It achieves the same outcome as option A, but with a bit more explicitness. Option C uses average equals binary This is only appropriate for binary classification problems, two classes, not for multi-class problems with imbalanced classes like I'm handling. I'm not using this one. Option D uses average equals none This will return an array of F1 scores for each class, instead of a single weighted average. This doesn't suit my needs. I need a single, summarized score for model comparison. Correct answers are A and B both create scores that calculate the weighted F1 score, which is exactly what I need for my imbalanced dataset. A is more concise. Both A and B are winners. I'm looking for the right way to make a scorer in scikit-learn that calculates the F1 score. The catch is, I need it to work correctly even when the classes in my data are not balanced, meaning I have unequal numbers of samples in each class. The solution needs to weigh the classes based on how frequent they are, giving less frequent classes more importance. I'll use the f1_score function from Sklearn. Metrics and make_scorer to achieve this. This option directly uses the f1_score function with the average parameter set to weighted. The weighted average calculates the F1 score for each class and then averages them, but it gives more weight to classes with more samples. This is exactly what I need for handling imbalanced classes! This does the same thing as option A, but it wraps the f1_score function inside a lambda function. A lambda function is just a short way to define a small, anonymous function. It's a bit more verbose, but functionally equivalent. This is incorrect because binary average is only for problems with two classes, binary classification. I need a solution that works for more than two classes, which this one doesn't. With average equals none the f1_score function returns a separate F1 score for each class instead of a single, overall score. This is not what I want, because I need a single score to compare models. The question asks which make_scorer call will create a scorer function that calculates the weighted F1 score, dealing properly with classes of different sizes. Options A and B are correct, while C and D are not suitable for this. I'm looking to build a function that scores a classification model, but I need to handle situations where some classes have far more examples than others. This is a common challenge in machine learning. This option directly uses the function with the average parameter set to weighted. This is exactly what I need, because it computes a weighted average of the F1 scores for each class. The weights are based on the number of instances in each class. This handles class imbalance well. This does the same thing as option A, but uses a lambda function. A lambda function is a small, anonymous function. This option wraps the function within a lambda expression to pass to makescorer. It's functionally equivalent to A, though maybe a bit less concise. Option C uses, which is only appropriate for binary classification, two classes, not for datasets with multiple classes and varying sizes. It won't handle imbalanced multi-class data. This will return a separate F1 score for each class without weighting. I don't want that. I need a single score summarizing the model's performance across all classes, and this one isn't giving me a weighted average. That makes this the least suitable option. The question asks me to select all the options that create a scorer suitable for imbalanced classification. This is the title describing the quiz. Sklearn is a popular Python library for machine learning, and we're focused on selecting the right function to compute the F1 score, a measure of a model's accuracy that considers both precision and recall. This reiterates the problem statement and why it is important to consider the class weights in this specific scenario. This question asks you to pick the correct way to create a function, a scorer, using Scikit-learn's makescorer that calculates the F1 score. The catch is that we need it to work well even if some classes have far more examples than others, imbalanced classes. We'll need to use weights to correct for this imbalance. This option directly uses the function with the weighted average. I think this is correct because the weighted average considers the number of samples in each class when calculating the overall F1 score, which accounts for the class imbalance. That's a really neat and clean solution. This option does the same thing as option A, but in a slightly more verbose way. It uses a lambda function to wrap the function, essentially creating an anonymous function. The result is identical. I get a scorer that computes a weighted F1 score, perfect for handling imbalanced classes. The lambda function adds unnecessary complexity here. This one uses binary average in the function. I find this incorrect because binary is only for problems with two classes. We're dealing with a scenario that might have multiple classes, so I need a weighted average to handle the imbalance correctly. I think this option is also wrong because setting average to none returns a separate F1 score for asterisk each class, not a single, combined score reflecting the performance across all classes. I need a single number summarizing the model's performance, and this doesn't give me that. I'm asking you to identify the correct make_scorer call that computes the F1 score, considering that we must handle imbalanced classes. This means I need a scorer that weights the classes based on their frequencies. Let's find the best fit. An imbalanced dataset has a disproportionate number of samples in each class. For example, if I'm classifying cats and dogs, and I have 90 images of cats and only 10 of dogs, it's imbalanced. Standard metrics can be misleading in such cases. This metric addresses imbalanced data by giving each class's F1 score a weight proportional to its number of samples. Classes with more samples will have a bigger effect on the final score. I want to make sure that I am weighting minority classes more accurately. I am trying to create a scorer using the make_scorer function from Scikit-learn. This will help me in calculating the F1 score and handling imbalanced classes effectively for my classification model using a weighted average. This will help me in model selection, ensuring a more robust evaluation process. It's all about choosing the right tool for the job. I am using =average equals weighted within the F1_score function. This tells the F1 score calculation to weight each class's F1 score according to the number of samples in that class. This is crucial for dealing with imbalanced datasets as it gives more importance to the often overlooked minority class. This is a function from Scikit-learn's =metrics module that computes the F1 score, a metric that considers both precision and recall. It's commonly used in classification tasks to evaluate a model's performance. It's a super important metric to ensure balance. This function, also from Scikit-learn, creates a scorer object. A scorer is a callable object that can be used by Scikit-learn's model selection tools, such as =grid search CV or =cross_val_score to evaluate model performance. It takes a scoring function, like our =F1_score and returns an object ready to use.